The title of this lesson is Pressure in a Liquid. Now this is different from pressure between two surfaces, which would have solid objects. This is the pressure on a solid object caused by a liquid. So we'll start with our key terms. We have pressure, force, surface area or area, density, gravitational field strength, Pascal, and depth. So start by stating the SI units of density and the SI units of gravitational field strength. And consider, why does it hurt your ears more the deeper you dive? Now this is a glossary of our key terms. I suggest you pause it now to read through them to make sure you understand, and if you'd like to write them down, by all means do so. So we're going to be dealing with a new equation. We have the quantities pressure, density, and gravitational field strength. Pressure in the equation is written with a capital P, and its units are pascals. Density is written with a rho, and its units are kilograms per meter cubed. And gravitational field strength is written with a lowercase g, and it is measured in newtons per kilogram. So here we have our equation. Pressure equals depth multiplied by density and gravitational field strength. Now you do not need to remember this equation, but you do need to know the meaning of each of these symbols. This equation will be given to you in the formula sheet. So let's look at an application of this equation. Calculate the pressure. So a rubber brick falls to the bottom of a 2.8 meter deep swimming pool. Given that the water has a density of 1,000 kilograms per meter cubed, calculate the pressure on that rubber brick. So the first thing we do is we write down what we've got. We know h, the depth, is 2.8 meters. We know rho, the density, is 1,000 kilograms per meter cubed. And we know g, the gravitational field strength on Earth, is 9.8 newtons per kilogram. Now, you can assume that it will always be 9.8 newtons per kilogram. I doubt you will ever find a question that suggests you are on a different planet or on a moon. So you can remember that g is 9.8 newtons per kilogram, unless your question has made it even easier for you by telling you that g is just 10. Step 2 is to write down our equation. Step 3 is to substitute in the numbers. So instead of h, I'm writing 2.8. Instead of rho, I'm writing 1,000. And instead of g, I'm writing 9.8. And finally, we write down our answer with the correct SI units. Now, notice here that the answer was 27,440 pascals, but I've chosen to make it to two significant figures. So I've said that P is approximately equal to 27,000 pascals because in the question it gave me two significant figures when it said 2.8 meters deep. Next, a metal bolt falls to the bottom of a 35 centimeter deep tub of oil. Given that the oil has a density of 870 kilograms per meter cubed, calculate the pressure on that metal bolt. So step 1, write down what we've got. Now notice it said 35 centimeters, and so I need to convert that to meters, the SI units. So that is 0.35 meters. Rho is 870 kilograms per meter cubed, and g is 9.8 newtons per kilogram. So we write down our equation in step 2. We substitute in those numbers in step 3, and it's your job to copy this all down and then complete step 4. Next, a submarine descends to the ocean floor around 1.2 kilometers below the surface. Given that the water has a density of 1,000 kilograms per meter cubed, calculate the pressure on that submarine. So we have step 1, write down what we know. Since it says 1.2 kilometers, we need to convert that into meters. So the depth is 1,200 meters. Rho is 1,000 and g is 9.8. So we write down our equation, and then you can copy and complete steps 3 and 4. Next, a whale descends to a depth of 0.75 kilometers below the surface. Given that water has a density of 1,000 kilograms per meter cubed, calculate the pressure on that whale. Copy this question down and complete all 4 steps. Now, sometimes you might be asked to calculate the depth. This time, a rubber brick falls to the bottom of a swimming pool and experiences a pressure of 32 kilopascals above atmospheric pressure. Given that water has a density of 1,000 kilograms per meter cubed, calculate the depth that rubber brick has fallen to. So step 1, we write down what we have. Now we know that 32 kilopascals is 32,000 pascals. The density of water is 1,000 kilograms per meter cubed, and g is 9.8 newtons per kilogram. The next step is to write our equation. Then step 3, we substitute in the numbers. So this time I replace p with 32,000. H stays where it is because that's what we're looking for, and then rho becomes 1,000 and g becomes 9.8. We rearrange in step 4 to make h the subject of the formula. So because it's h times by 1,000 and times by 9.8, we do the inverse operation, and so we do 32,000 divided by 1,000 times 9.8. And finally, we write down our answer with the correct units. Now here we can see that the depth is 3.265 meters. Since I was given 2 significant figures in the question, I have chosen to say that the depth is approximately 3.3 meters. Next, a metal bolt falls to the bottom of a tub of oil and experiences a pressure of 1.6 kilopascals above atmospheric pressure. Given that the oil has a density of 870 kilograms per meter cubed, calculate the depth of the oil. So we write down what we know. Since it was 1.6 kilopascals, that's 1,600 pascals, we have 870 kilograms per meter cubed and 9.8 newtons per kilogram. So then we write our equation, then we substitute in our numbers, and then we rearrange to make h the subject of the formula. Copy this down and complete step 5. A submarine can withstand a total pressure of 23 megapascals above atmospheric pressure. Given that the water has a density of 1,000 kilograms per meter cubed, calculate the maximum depth to which that submarine can descend. So this time we have megapascals. Mega means 1 million. So we have 23 million pascals. So we write down what we know, then we write down our equation, we substitute in the numbers. Now notice here that I have used standard form. The reason I did that was actually just because I ran out of space in that box. But it is useful to write down in standard form in your calculator when there are a large number of zeros at the end of your number. And then you're going to copy this down and complete steps 4 and 5. Finally, for calculating depth, a whale can withstand a total pressure of 29 megapascals above atmospheric pressure. Given that water has a density of 1,000 kilograms per meter cubed, calculate the maximum depth to which the whale can descend. Complete all of the steps this time. If you need any help, you can always go back to the previous questions to look at how to solve this problem. Moving on, application questions. So explain why a whale needs an especially strong rib cage when diving deep into the ocean. A whale needs a strong rib cage because, now I've put those words in red because you do not need to write them in the exam. They're useful to give context in your notes to say what you're talking about, but in the examination, they've literally just asked you the question. There is no need to repeat the question in your answer. So those words in red are completely useless words in your examination. They just waste time. So, the greater the d in the ocean, the larger the p on the whale. This causes a large f on the ribs, which would cause them to crack if they were not strong enough. So copy the question out and complete the answer. Next, explain why a dam needs to be thicker at the base than the top. A dam needs to be thicker at the base than the top because the greater the something in the water, the greater the something. This means there will be a larger something at the base of the dam, so it needs to be thicker to be strong enough to hold against that something. Copy the question and complete this answer. And finally, a cylinder of water has 2 holes in it at different heights. Explain why the water coming out of the bottom hole comes out quicker than the hole above it. The water comes out of the bottom hole quicker because the greater the something in the water, the greater the something. This means there is a larger something on the water coming out of the bottom hole, so it comes out faster. Copy this question down and complete the answer. Now finally, before we finish, I did ask at the start to consider why is it your ears hurt more the deeper you go. I would like you to consider what you've learned. The deeper in the ocean or the deeper in the swimming pool you go, the greater the something on your ears. And that's the end of the lesson.